Good morning, student. The today's topic is network layer design issues. So let's start with today's lecture. The network layer or the layer 3 of the OSI model is concerned about the delivery of the packets from the source to the destination across the multiple hops or the links. So what is the major functionality of a network layer is to send the data packets from source to destination across the multiple systems. What it means, whenever anyone who sends the data, that data is safely reached at the destination part across by crossing the number of systems or the number of links that are passing through in between them. It is the lowest layer that is concerned with end-to-end transmission. This layer is concerned about the end-to-end transmission, and end-to-end transmission means a system-to-system transmission. The designer who are concerned with designing this layer needs to cater to certain issues. A designer, or you can say a manufacturer, or who design the working of this network layer, they have to need to add the number of features in the particular network layer, and these issues encompasses the services provided to the upper layer as well as the internal design of the layers. And these issues are regarding concerned with the services provided to the upper layer, as well as these issues can be concerned about the design of this particular layer. As we discussed earlier, design of the particular layer means the attributes of these layers, or you can say the functions performed by this layer. So let's start the functions performed by these layers. The design issues can be elaborated under the four heads. Now we have the four major categories. Here we can define the design issues that are come under the design issues of the network layer. The first is store and forward packet switching. Second, services to the transport layer. Third, providing connection-oriented services. And the last one is providing connectionless services. So let's start with discussing one by one. The first is store and forward packet switching. The network layer operates in an environment that uses store and forward packet switching. The node which has a packet to send delivers it to the nearest router. The packet is stored in the router until it has fully arrived and its checksum is verified for the error detection. So what it means, store and forward packet switching means whenever we suppose we send some data, suppose A is the sender and B is the receiver. So what will happen under this layer, whenever A sends the packet, that packet is first received by the nearest router. Whenever that packet is received by that particular nearest router, it temporarily stores the data on that router, then confirm its routing algorithm, then goes from that particular router to the next router. And again, whenever it's reached to the next hop, next node or next router, anything else, it reaches on that router. Again, it temporarily stores the data on that router and moves further to the next router or the next hop. This process will continue until your packet is received by the receiving device. That's why the name is store and forward packet switching. Once this is done, the packet is forwarded to the next router, as we discussed. Since each router needs to store the entire packet before it can forward it to the next hop, the mechanisms is called store and forward switching. So this is the process of the store and network, store and forward packet switching. So again, I am repeating this. Store and forward packet switching means whenever you send the packet, that packet is received by the number of hops, number of packets, or the number of systems until it reaches to the destination. The number of hosts or the number of routers that are received by these packets, they are temporarily stored on that particular routers. So this is all about the store and forward packet switching. Now the second one is services to the transport layer. The network layer provides services. It's immediate to the upper layer that names transport layer through the network. Transport layer interface through the help of transport layer interface. What it means, the upper layer of this layer is the transport layer, and the services provided by this layer, the network layer, directly to the transport layer through the transport layer interfaces. The two types of services provided, that one is connection oriented services, connection oriented services. And this services, a path is set up between the source and the destination, and all the data packets belonging to a message are routed along this path. And the second is connectionless services. In the services, each packet of the message is considered as an independent entity and is individually routed from the source to destination. So second one is the services provided to the transport layer, and transport layer is the upper layer. So it can provide the two type of services to the transport layer. Basically, it sends the data towards to the transport layer. So the two services are the connection services, and the first one is connection oriented and the second one is connectionless. The next is providing connection oriented service. In connection oriented service, a path or a route called a virtual circuit is set up between the source and the destination nodes before the transmission starts. All the packets in the message are sent along the route. Each packet contains an identifier that denotes the virtual circuit to which it belongs. When all the packets are transmitted, the virtual circuit is terminated and the connection is released. An example of the connection-oriented services is multi-protocol label switching. So, what is connection-oriented services? Connection-oriented services means the first thing is that a virtual connection is made. The name is connection oriented. So we know the connection is made. A virtual connection is made between the sender and the receiver. So what it means, all the transmission that can be happened between that particular sender and receiver, all the packets can follow the same route. Which route? The connection that is made between the sender and the receiver. And every packet in this transmission, they have an identifier which denotes the route of that virtual circuit. So what it means, a predefined path, you can say a predefined path or a predefined circuit, a virtual circuit is created, and all the transmissions that can be happen. So what it means, all the packets, they have to follow the particular path. This is all about the connection oriented services. Now the last one is providing connectionless service. As the name implies, the connectionless, what it means, the no connection is there. In connectionless service, since each packet is transmitted independently, each packet contains its routing information and is termed as datagram. The network using datagrams for transmission is called datagram network or datagram subnets. Now, prior setup of the routes are needed before transmitting a message. Each datagram belongs to the message, follows its own individual route from the source to destination. An example of the connectionless services is IP protocol, or you can say internet protocol. So what can be happened in the case of connectionless services? The first thing is no connection is made. If the no connection is made, then it depends upon the different packets who are to be transmitted. They can be follow any of this particular route. So what it means, all the packets, they are independent. Why they are independent? Because the no route is there. They have the multiple routes. They have to follow any route. And the next is the packets that are transmitted in the connectionless services. They are called the datagrams. And that particular network is called the datagram network, or you can say the datagram subnet. And no setup of the network is created priorly. That can be happen in the case of connection oriented. So connectionless services, they are completely works opposite as compared to the connection oriented services. Okay, the next topic is IPv4 addressing. That is IPv4. What is IPv4? Basically, IP means the internet protocol and V4 means the version 4. IPv4 stands for Internet Protocol version 4. And IPv4 addressing, we have the two types of addressings are there, the classful addressing and classless addressing. So let's start with the first, the classful addressing. IPv4 addressing used the concept of classes. They have the concept of classes are there. The classes are made in the cases of classful addressing. This architecture is known as the classful addressing. Whenever you are using some classes in the addressing scheme, this is known as the classful addressing. In the classful addressing, there are 5 classes in which address space is divided. Now, in the case of classful addressing, we have the 5 different classes, and the names of these classes are A, B, C, D, and E. Each class occupies some fraction of the address spaces. Some fraction of address space means each class they have some defined addresses. Some defined addresses can be reside under every class. We can find the class of an address when given the address in binary notation or the dotted decimal notation by checking the first few bits or the first bytes. So simply we come to know about the address belongs to which class, simply checking the binary notation or the dotted decimal notation by checking the first few bits or the bytes. That first few bits or bytes, they denotes the particular address is belongs to which class. With the help of these, we just simply come to know about that particular address belongs to the which class. Either it belongs to A, B, C, D, or E. So this is the classful addressing. Now the classless and blocks. The classless addressing also consists of the blocks. So what will happen? There is a problem with the classful addressing that is each class is divided into a fixed number of blocks with each block having a fixed size. Now, as we discussed the classful addressing, in classful addressing we are using the classes and the addresses that are divided according to the classes, and each class that comprises of some addresses. But the problem is there, whenever we are using the classful addressing, each class is divided into a fixed number of blocks. Fixed number of blocks means they have the fixed size, and these fixed size can contain the number of addresses. Clear? So this is the example of the classes. Like the first is the class name A, B, C, D, and E. Now they have the number of blocks. Number of blocks means the total fixed blocks that contained by that particular class. Now that the first class is 128, 128 blocks are there. In B, 16384 blocks are there. In C, 2097152 blocks are there. D and E only contain the one block. Now the block size. These are the block sizes that given to the particular block as given to the A, B, C, and D. Now the application. Application means either they are the unicast or they are the multicast. The first three A, B, C, they are the unicast. In the D and E, they perform as a multicast. So the Class A addresses are designed for large organizations to manage a large number of attached host or router. What it means? The Class A addresses, they are used by the big organizations. Why? To manage the large number of systems. Because whenever a large number of systems can consist by an organization, they have to give the different or unique IP addresses to each and every system that is the part of that organization. Clear? So this is all about the Class A. Now the Class B addresses are designed for mid-size organizations to manage tens of thousands of attached hosts or routers. So what it means, whenever organization size is comparatively less, then we go for the Class B addressing. Now the Class C, whenever the Class C address are designed for small organizations to manage a small number of attached hosts or routers. So what it means, whenever a class size is less, then we use the class C. So this is all about the class A, class B, and class C. Next is classless addressing. Classless addressing leads to the address depletion. That's the big issue for this scheme, and that's why it's not used nowadays. Now the bigger problem is address depletion. Address depletion means the complete addresses are not contained by the classless addressing because no classes are there. If the no classes is there, so the number of fixed blocks are not there. If the number of fixed blocks are not there, so they are very reduced in size. They are very small in size because the blocks, they have the fixed size, the no size is there. So they are not, it's not easy to give the maximum number of addresses to the organization. That's why this classless addressing is not used nowadays. To overcome the problem of address depletion, and to give more organization access to the internet, the classless addressing was designed and implemented. And this scheme of classless addressing, there are no classes, but the addresses will still granted in blocks. Now, the no classes are there, but we have the reduction. We have the address depletion. Address depletion means we have the less amount of size. We have reduction in addressing scheme. With the reduction in addressing scheme, so what it means, they have the small number of addresses it contains, but these addresses are granted in blocks, but the size of block is very less. That's why the name is classless addressing. Clear? Okay. Next is address blocks. In classless addressing, when an entity needs to be connected to the internet, it is granted a block of addresses. A block of addresses or a range of addresses or the combination of multiple addresses. The size of the block varied based on the nature, size, and need of the entity. And that the size of this particular block, it is depends upon the nature of the entity or the nature of that system, or you can say the nature of the organization. Nature means what is the complete size of this organization. Complete size in the terms of number of systems. Total number of systems who are going to be assigned new addresses, it depends upon that. For example, a household, a small organization may be given only 2 addresses. A large organization may be given 1,000 of addresses. On the other hand, an ISP, that is internet service provider, as the internet service provider may be given hundreds of thousands based on the number of customers it may serve. So what it means, whenever addresses or the address block is given to a small organization or homely organization, only the 2 addresses can be given, because we know the 2 addresses are more than enough to arrange the number of systems to small organizations. But whenever we are giving these address blocks to a bigger organizations, then the number of addresses that are given to the bigger organizations, they are the large organizations. So the thousands of addresses are given to these organizations. So the address block is larger as compared to the address block that is given to the household organizations. Clear? So next is the 3 restrictions on classless addressing blocks. Now we have the 3 restrictions that are applied on the classless addressing blocks. The first is the addresses in a block must be contiguous. That means one after another. They are in the continuous form. For example, suppose we give the address block in the case of classless addressing. The block size is 10. So what it means, the addresses names are 1, 2, 3, 4, 5, 6, 7, and 9, 10. They are the continuous in the situation. Clear? Second, the number of classless addresses in a block must be a power of 2. They are the simply and the mathematical equations. The number of classless addresses in a block must be a power of 2. The value is power of 2 is there. Of the power of 2 means any value that is the power of 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Make the power of 2. What is the value? You can make a address block in the case of classless addressing. And the last one is the first address must be eventually divisible by the number of addresses. The first address means the initial address of this block that is divisible by the number of addresses. Why it is divisible? Because we are going to make an address block is a power of 2, and the power of 2 means all are the even numbers. If the even numbers are there, they are simply divisible by that particular address. So these are the three restrictions that are mandatory, can be applicable on the address blocks only in the case of classless addressing. So this is all about the classful addressing and classless addressing. Now we have the next topic, that is subnetting. Now, what is subnetting? When a bigger network is divided into a smaller networks in order to maintain security, then that is known as subnetting. So the maintenance is easier for smaller networks. Now uh, let's talk about dividing a network into two parts. So to divide a network into the two parts, you need to choose one bit for each subnet from the host ID part. So what it means, first try to understand what is subnetting. Suppose we have a network, we have a bigger network, we are giving the number of IP addresses to our each and every system. Suppose we have a network of 10,000 systems, and it is very difficult to maintain that network. So we are going for a subnetting. The process of subnetting means now we are going to divide that bigger network into a smaller network. Right now I have a 10,000 systems. I make a subnetting. Now I having a two subnets are there, subnet 1 and subnet 2. Now each subnet is consist of now the 5,000 number of systems. Now it's easy to maintain the security and easy to maintain the systems as a power of 5,000 as compared to the total number is 10,000. So whenever we are dividing the bigger network into a smaller network, it is known as subnetting. So we have an example over there. Now look at here, NID. Look at the diagram. NID means the network ID. The network ID is 193.120. This is the network ID, or this is the complete organization ID. Now we are dividing the subnetting. Now this subnet network ID is divided into the two parts. Now consider this. This is a subnet 1, subnet 2. Now the subnet 1 ID is, now the network ID is 193.120.00000. What it means? It starts from the initial value, but it is different in the case of subnet 2. Now look at here on your screens. NID is 193.120, and it starts from 1000000. So what it means, the values that are less than this value is 1000000. All the values that are less than this values, they are contained by subnet 1. I just give you an example. A simple example is over there. Suppose a subnet 1 network ID is 193.120.00000. Four zeros are there. And subnet 2 IDs network ID 193.1.2.1000. 1000 means 1000. So what it means? 999. The value less than 1000 is 999. What will happen? 999 addresses, they are given to the network ID of the subnet 1. Clear? Now the range 193.1.2 from 0 to from 193.1.2 at 0.0111. If we consider the previous example, then the value is from 193.1.2 and 999, because the subnet 1, they have the range from 0 to 999, and subnet 2, they have the range for 1000 to 1999. Clear? So this is all about the subnetting. In the above diagram, there are the two subnets, and we are dividing the subnet 1 and subnet 2. And the major thing is, or the thing that you remember is network ID. They have the network ID, but whenever we make a subnetting, we are going to make a subnetting, we are making a subnets. So that network ID is divided into between the subnets. Now, it is a class C IP. So there are 24 bits in the network ID part and 8 bits are in the host ID part. What it means, take the example of A, B, C, D, E classes. For the subnet 1, the first bit which is chosen from the host ID part is 0 and the range will be from, and the range is simple 193.1.2000 till you get all the ones in the host ID, like last 0 and all are the 1. This is the complete range given to the subnet 1 except for the first bit which is chosen 0 for the subnet ID part. Thus the range of the 1 is from 193.120 to 193.122 to 127. Clear? Power of 2, they make the decimal value, so they give the value 127. Now for the subnet 2, the value starts from 1, then 00000, and value goes to the 193.121111111. Thus the range of the subnet automatically, the range of the first subnet starts from 193.120 from 0 to 127. Automatically second starts from 128. It starts from 128 and ends at 255. So these are the ranges that are given to the subnet 1 and subnet 2, and these range can be depends upon your network ID, the complete ID that is given to the complete organization.